Hello, today we're going to be talking about the fundamental counting principle. We have a problem that says you are the you are in charge of city transportation in the city of Upper Arlington. How many different distinguishable ways can someone travel from point P to point Q if he or she must always make progress towards point Q? So here, there are three different pathways. There's pathway P to A, pathway P to C, and pathway P to F. Those are the starts of each direction towards Q. Pathway P to A goes P to A, then A to B, then B to Q. From P to A, there is one option. From A to B, there is one option. And from B to Q, there are two options. Then from P to C, there is one option. From C to D, there are three options. And from D to E, there are two options. And from E to Q, there is one option. And finally, from P to F, the third way, there are two different options. And then from F to Q is one option. So we need to figure out how many different routes there are to get from P to Q. So we take the different ways from the P to A path. So we had P to A, which is 1, and then A to B, which is 1, so 1 times 1 is 1. And then B to Q is 2, so 1 times 1 times 2 is 2. Then we have the P to C path. P to C has one option, C to D has 3, so 1 times 3 is 6. D to E has 2, so 1 times 3 times 2, or 1, sorry, I apologize, 1 times 3 is 3. Then we have 3 times 2 is 6. And finally, E to Q has one option, so 6 times 1 is 6. So on the P to C path, there are 6 ways. And finally, we have the P to F. From P to F, there's two options, and from F to Q is one option. So 2 times 1 is 2. So we take the final amount of routes for each three, P to A, P to C, and P to F. 2, 6, 2. We add those up, and we have 10. That is the answer, 10 distinguishable routes. We have a second problem where it says 126,000 has a prime factorization of 2 to the 4th times 3 to the 2nd times 5 to the 3rd times 7. It says use the fundamental counting principle to determine how many positive divisors number 126,000 has. So you could use the fundamental counting principle, create a tree. It would take a long time. That'd be difficult. Or you can look and say, well, 2 to the 4th, you can have either 1 2, 2 2, 3 2s, 4 2s, or 0 2s, which means there's 5 different options for the amount of 2s you can have. So we have 5 2s. Then for 3s, you can have 1 2 or 1 3 or 2 3s or 0 3s. So that's 3 different options for 3s. I assume you'll pick up on the pattern that it's just one more than the exponent on the number. So that means we will have 4 5s and 2 7s. If you multiply 5 times 3 times 4 times 2, you'll get 120. And that is the amount of positive divisors the number 126,000 has. I hope this helped. Thank you.